स्टूडेंट्स ASK की बात चल रही है. हम लोगों ने एम्पलीट्यूड शिफ्ट कीइंग को देखा था कि हाउ डज इट हैपन एंड व्हाट आर द डिफरेंट bandwidth implications, the carrier frequency, and the actual relationship of the bandwidth with the signal rate that is involved with ASK. Students, अब देखेंगे कि how can we implement binary ASK. In the example of this implementation of binary ASK, we'll see how, in essence, the implementation happens in the case of binary ASK. The actual implementation is really complex, but we'll just give you a slight background on a high level for you to understand how the binary ASK works. Students, in this case, the digital data that we are using, it is presented as a unipolar NRZ signal. Remember from our discussion of the line coding scheme, the unipolar NRZ has got a high level of 1. So the high voltage level in this case is going to be 1 and a low voltage level of 0. So this is our digital data presented as unipolar NRZ, and this is what we need to send from point A to point B. Students, in this particular case, what we do is we have got an oscillator. The frequency is the carrier frequency, FC. We take our unipolar NRZ signal and we multiply that with the oscillator the oscillating signal which is produced at a frequency of FC. Students, as you can see, wherever we had a 1, the carrier signal that's produced by the oscillator, in the modulator signal, wherever we have a 1, the amplitude of the carrier signal is maintained. Now, students, ASK karte hue, wherever we have a 0, which is this case, the amplitude of the carrier signal is made 0 or is reduced to 0 voltage as compared to the amplitude in the carrier signal. So, in essence, what we are doing is, in the case of 1, we are maintaining or holding amplitude of the carrier, and in the case of a 0, we have a 0 amplitude. Students, once again, this carrier signal that you are looking at, it serves as the base of the information that we are going to be carrying. So this carrier signal that's produced by the oscillator. This is serving as the base of the unipolar NRZ digital signal that we have out here. And the result is a modulated signal that is what's going to be sent from the sender to the receiver. So students, we'll do an example. In this case, we have an available bandwidth of 100 kilohertz, and it spans from 200 to 300 kilohertz. Students, we need to find the carrier frequency, and we need to find n, which is the bit rate. If the data is modulated using ASK with d is equal to 1, and we are using one signal element per data element, so our r is equal to 1 as well. Students, the middle of the frequency is 250 kilohertz, so our carrier frequency is going to be 250 kilohertz. Now we have the formula of the bandwidth for ASK, which is 1 plus d into the signal rate. Bandwidth is proportional to the signal rate. Students, inserting the value of d, we come out with 1 plus 1 into s. So your bandwidth is equal to 2s. Let's insert the value of the signal rate, which is n over r. Students, bandwidth is equal to 2n, and the reason for that is because our r is equal to 1. And this comes out to be, from this discussion, our n is equal to be bandwidth divided by 2, which is equal to 100 kilohertz divided by 2, and so our data rate is equal to 50 kilobits per second.